Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 1 and 2 class. Today we're going to be talking about solving rational equations. And a rational equation is an equation which contains at least one rational expression. That means that there is a variable in the denominator. You can simplify solving a rational expression by eliminating the denominators. And you can eliminate the denominators by simply multiplying the LCM, or LCD in this case, because they're denominators, of the rational expressions to both sides of the equation. Performing these operations can lead to what's called extraneous solutions. So all answers must be checked for accuracy. An extraneous solution, again, is a solution that you will find, but when you plug it back into the equation, it's going to render you a wrong answer or an undefined situation. So you must check your answers. Now here, as you can see on the left equation, this is a rational equation because there are denominators that include variables. On the right side here, this here is not a rational equation. That is just simply an equation. In fact, it's a single step equation. There are no variables in the denominators. So if there are no variables in the denominator, that's easy. We know how to do that with our eyes closed. When you have variables in the denominator, that's when we have to eliminate these denominators by multiplying by the LCD to both sides. For example, let's get right to it. We have in example number 1, 3 over 2b minus 1 equals 4 over 3b. So the first thing we want to figure out is, what is the LCD? Yes, sir. It's not going to be 6b minus 1. No. Remember that when we're doing LCD, what's the LCD of just the numbers?
There's not.
Yes, there is. The numbers are 3. What about the single variables alone? B. What about the polynomials? So what is the LCD here, my brothers? 3b times 2b minus 1. Okay? That is the LCD. So what am I going to multiply to both sides of this equation? Okay, no. Some of you aren't paying attention here. No. You're going to multiply everything by the LCD. You're going to multiply to both sides here 3b times 2b minus 1. And 3b here times 2b minus 1. When this occurs, guys, what is 2b minus 1 divided by 2b minus 1? It cancels. So what am I left with in the numerator? 9b. Fantastic. Over here, what is 3b divided by 3b? Cancels. So what am I left with in the numerator? 8b minus 4. Fantastic. Now it's simple, my brothers. Subtract 8 to both sides, 8b, and b equals negative 4. However, you must check the answer. So that means you have to plug this b back into the original equation and see if it does work. So I'm going to plug it back in. 3 over 2 times negative 4 is negative 8 minus 1 is negative 9. Does that equal 4 over 3 times negative 4 is negative 12? If I reduce, this is negative 1/3, which equals negative 1/3. So yes, that is the solution. Does that make sense, gentlemen? You promise? Okay. Number 2. What do you think I'd have to do first here before I find an LCD? Yes, sir. No. You don't want to add the fractions together. That's going to make, you could, but that's going to make your life double hard. You want to simplify all of the denominators first by factoring. So we have 4/3 plus 7 over x minus 4 equals x minus 1 over 3 times x minus 4. Now, what's my LCD, gentlemen? Excellent. 3 times x minus 4. Does that make sense, gentlemen? You promise? Okay, so what am I going to multiply to both sides of the equation? Not to both, yeah, to every single thing, to both sides. I'm going to multiply to every single thing here 3, and you know what? Let me make it a little bit easier for you. Because if I do it that way, you got to distribute. But I want to show you that you're multiplying it to every single numerator. So here you're going to multiply a 3 times x minus 4. Here you're going to multiply a 3 times x minus 4. And here you're going to multiply a 3 times x minus 4. Now, why do I do it that way? Because in this first part of the equation, the 3's cancel. So what am I left with? 4x minus 16. Absolutely fantastic. Next, what cancels here? X minus 4. Fantastic. See how beautiful this is, guys? This gets rid of the denominator. Boom. Bye-bye. Have a good day. Here, what gets excuse me. Let's put that away. The entire denominator gets canceled with the 3 times x minus 4. Excellent. And now I have x minus 1. Now it's really simple. I've got 4x plus 5 equals x minus 1. Subtract the x, good man. 3x, and then subtract 5 equals negative 6. Excellent. Divide by 3. So x should equal negative 2. Okay? But we've got to check here. All right? So let's check. So does 4/3 plus 7 over negative 6, right? Because negative 2 minus 4 is negative 6. Does that equal negative 3 over negative 6 minus 12? That's negative 18, correct? Negative 18. Okay. So basically, this turns to a 6. This goes to an 8. Right, my brothers? So 8/6 minus 7/6 is 1/6. And I can reduce here by dividing negative 3 to top and bottom, which equals 1/6. So it works. Yes, sir. You have a question, my man? Okay, why? This negative in the denominator just makes this whole fraction a negative. Thank you, sir. Thank you very much. Does that make sense, gentlemen? You promise? Questions on this so far? Yes, sir. Because I found a common denominator, my man. 4/3, I got to make that denominator a 6. So I multiplied 2 to both top and bottom, which is 8/6. Okay, thank you very much, sir, for your honesty. Any other questions, gentlemen? Okay, let's move on. Now, let's get a little bit more complicated here. All right? Here in this particular case, what do you think I want to do first? Factor out the denominators for sure. Do I factor out the numerators as well? Do you think? You can. You don't have to, but you know what? Sometimes what happens is when you factor out the numerator and the denominator, you can cancel something out, right? So let's factor everything out here. So I've got x plus 4, and x. No, you can't factor that out, actually. 6, you can't factor it out. What times what is 6 when I add together is 8? Nope, so you're out of gas there. So I have here x plus 6. Okay. Now, down here in the denominator, what times what is negative 4, but when I add together is positive 3? Positive 4, negative 1. Excellent, sir. Here, I've got 3 over x minus 1 minus 2 times x plus 4. What is my LCD here, gentlemen? X minus 1 times x plus 4. Don't stress out. I promise you, when you multiply this LCD out, life gets a lot easier. So I am going to literally, let me move this out here so I have a little bit more room. You are going to literally multiply this here by x plus 4 times x minus 1. You're going to multiply this guy here by x plus 4 times x minus 1. You're going to multiply this guy here by x plus 4 times x minus 1. You're distributing that LCD to every single term of the equation. Now what happens here, guys? On the left side, everything cancels. You're done. Beautiful. X squared plus 8x plus 6 equals. Very good, son. The x minus 1 cancels. I'm left with 3x plus 12. Very good job, son. What about over here, my brothers? Very excellent. I'm very proud of you, but it's plus 2. The x plus 4's cancel, but I have a negative 2 that I've got to distribute, so be careful. This becomes negative 2x plus 2. You're done. Now, I'm going to go ahead and create one trinomial, and I'm going to factor and use the zero product property to solve. All of our skills are coming together here. So 3x and negative 2x is a positive x. So I'm going to subtract 1x to both sides. And 12 plus 2 is 14. So I'm going to subtract 14 to both sides. You guys see what I did there? I skipped a little bit. Okay. So then this gives me x squared plus 7x minus, come on, minus 8, correct, equals 0. Now I'm going to factor. What times what is negative 8, but when added together is positive 7, gentlemen? Excellent. Positive 8 and negative 1. Using my zero product property, what does x equal? Negative 8 and positive 1. Okay. Very good. Now, right off the bat here, guys, when I plug in 1 into this denominator here, doesn't that become undefined? That is my extraneous solution. So x equals negative 8. 1 is really extraneous. You feel me? Yes, sir. No, you're not going to ever have a possibility where both answers are extraneous. No, sir. It won't happen. Really, the trick here is, really, to be honest with you, plug in the answer into any of the denominators. If any of those come out to be 0, that's your real extraneous one. No, both could be correct, yes. But sometimes one is extraneous. That's why you have to check. Okay? Hold on. Let me reduce this real quick so we could see everything together. Yes, sir?
So what if you put both the solution to the denominator, either like is equal to 0, does that mean you still have to plug in the solution?
No. If you have no answers that render you with an undefined solution, they're both going to be, it's going to work. I promise you. Okay? And look, just so you can see, negative 8 squared is 64. 64 minus 24 is 40. 40 minus 4, that's 36. That's not 0. So you're basically looking for the x that gives you zeros in the denominator. You with me here, gentlemen? Promise? Okay. Questions so far? We're good? Okay. Now, let's go ahead and do this guy here. Let's actually bring up. Let me bring this guy down. Make our lives easier. Okay. So, what do we have to do first here, gentlemen? Simplify the denominators, absolutely, and then find the LCD. Absolutely. Great job, gentlemen. Yes, sir. Well, we had that situation already. If you were to multiply these two together, it gives you this. So what? You're still going to multiply by the LCD. Thank you, sir. Good question, sir. Okay, so this is going to equal, and actually up here I can factor this out, actually this time. Yep, x plus 1 and x minus 2 over x minus 4 times x minus 2. Great job, guys. Now, look at how beautiful this is. Look at how beautiful this is. This cancels out right from the beginning. Remember, you cannot factor out individual pieces of a polynomial, but you can factor out polynomials straight up. Does that make sense? Okay, but you know what? When I'm looking at this, does it really matter doing that? No, because you're still going to have to multiply everything by x minus 4 times x minus 2. So this x minus 2 is going to come back to haunt you anyways. So you know what? Let's not factor the numerators. Just factor the denominator. It's not really going to matter ever for you. In fact, by factoring the numerator, you're going to complicate things more. So just stick to factoring the denominators. Trust me. Trust me, trust me, trust me. X minus 4 and x minus 2. Okay, so my LCD here in this case is x minus 4, x minus 2. So I'm going to multiply every single numerator by x minus 4 times x minus 2. And you see what I mean here? Had I eliminated the x minus 2, I'd still have to multiply the x minus 2 back to this. So it doesn't really matter. So here I eliminate the x minus 4, and I'm left with 6x minus 12. Great jobs, gentlemen. Next one, I cancel out the x minus 2, and I'm left with 3x minus 12. Excellent, gentlemen. Here, this cancels out the whole entire denominator. I'm left with x squared minus x minus 2. Go ahead and set up a trinomial again. 6x and 3x is 9x, so I'm going to subtract 9x to both sides. And negative 2 and negative 12 is negative 14, so I'm going to add 14 to both sides, leaving me with 0 equals x squared minus 10x plus 12. Does that make sense? Yes, sir. Come again? 6x minus 12. Why 6x? Hold on, hold on, hold on, hold on. Yes, it would have been. How about Mr. Morrow? Pay attention and learn how to multiply. Thank you, son. Let's do this again correctly. My bad, no excuses. 6x minus 12. That's where I messed up. Thank you, sir. Plus 3x minus 12. Wow, that was silly of me. X squared minus x minus 2. Thank you, son. So this is 9x. I'm going to subtract 9x, and that's negative 24. So I'm going to add 24 to both sides. Thank you so much, son. Thank you very, very much. You guys are awesome. Okay, so I'm left with 0 equals x squared minus 10x plus 22. Right? Huh? Let's see here. We cannot factor that. Well, we can complete. No, I haven't done completing this. We can't complete the square with you guys either. No, I have not taught you how to complete the square. And I have not taught you how to do the quadratic formula, have I? Yeah. Okay. Here I went a little bit ahead of what we really should have done here. In this case, what we'd have to do is do something called completing the square, or the quadratic formula, but I have not taught you either one of those. Correct? Okay, so what we're going to do is when you get to this part for now in our class, you can leave it like this and stop. Because it's not fair for me to now teach you the quadratic formula just for one example. That's not fair. You with me? What I will do though is I will make sure that I always leave you with things that are factorable. After this chapter, we're going to learn how to complete the square and do the quadratic formula. But for now, I don't want to do that. I went a little too advanced. Okay? Does that make sense though, guys? Okay. Next. Okay. Let's see what we got here. Solve each of the following rational equations. Okay. What's the LCD here? So I'm going to multiply x plus 2 to both sides. Cancels. Cancels. So I've got x minus 1 equals x squared plus 2x minus 3. Subtract x and add 1. Subtract x and add 1. So I've got 0 equals x squared plus x minus 2. What times what equals negative 2, but when added together is positive 1, gentlemen? Plus 2 and negative 1. So x equals negative 2 and 1 using the zero product property. But look, can I have x as a negative 2? No. So that's extraneous. So x only equals 1. In my opinion, this is a lot easier than adding or subtracting or even multiplying or dividing. Yes, sir, you have a question, my brother?
Yeah, actually, once you get x minus you don't have to check, right? Because that's
Wait, no. What you said was completely wrong. Once you just said to me, once you get x minus 1, you don't have to check. No, there is no x minus 1. X equals 1, and I did check. When I plug this into the denominator, do I get a 0 in the denominator? So you're fine. Thank you, sir. All right, what's the LCD here for number 6, gentlemen? X plus 2x minus 2. So I'm going to multiply x plus 2x minus 2 to both sides. X plus 2, x minus 2 to both sides. X plus 2, x minus 2. Got to multiply it to everything. Don't forget to multiply it to that 1 as well, please. So the x plus 2 here cancels. What am I left with? 2x minus 4. Correct. Excellent. Here the x minus 2 cancels. What am I left with? X squared plus 2x. You guys are awesome. And then, no, but what's x plus 2 times x minus 2? Very good. That's the difference of squares, right? So this is simply x squared minus 4. If you want to do it the long way, you can, but you will realize that the middle ones cancel out. That's why all the things that we learned before, it's important for you to really know them. Now here in this situation, I have an x squared on this side and x squared on this side. So don't those just cancel? I have a negative 4 on this side and a negative 4 on this side. So don't those just cancel? So I have 4x equals 0. X equals 0. Can I have a 0 as an x here in the denominators? Absolutely, because 0 plus 2 is 2. 0 minus 2 is negative 2. Up here it's 0. 2 over 2 equals 1. It all works out. Does that make sense, gentlemen? Talk to me, boys. I see some of you with a little bit of confusion in your face. Please talk to me. I'm here for you. Yes.
Like, I noticed
Go ahead. You notice what?
you have the x plus 2x minus 2 as the denominators, and you're adding them on this side of the equation. Like, you find the LCD for those, and then just multiply it to the other one. But how about for number 5? Like, I didn't know what you did there.
What do you mean? The LCD was x plus 2, son. What do you mean you didn't get what I did there? I did the same thing. I multiplied the LCD to both sides. It is the LCD. The LCD is x plus 2. They both have the same denominator already. Thank you, sir. Okay, number 7. Okay, now we're getting fun. This is x minus 1 over, what does this factor out to be? X plus 1, x plus 2, plus 2x over x plus 2 equals x minus 1 times x plus 1. What's the LCD here? X plus 1, x plus 2. So I'm going to multiply here and x plus 1, x plus 2. Here I'm going to multiply on x plus 1 times x plus 2. And here I'm going to, bless you, multiply on x plus 1 times x plus 2. All right. So the x plus 1, x plus 2 cancels each other out here, so I'm left with x minus 1. Here the x plus 2 cancels, so what am I left with? Remember, I got to distribute the 2x. No, 2x squared plus 2x, excellent. And then here the x plus 1 cancels, so I have to FOIL. X minus 1 times x plus 2. X times x is x squared, plus 2x minus x is plus x minus 2. Okay? Let's sharpen this up a little bit. This is 2x squared plus 3x minus 1 equals x squared plus x minus 2. I'm going to subtract x squared and x, and I'm going to add 2 to both sides. Subtract x squared, subtract an x, and add 2 to both sides. So I'm left with x squared plus 2x plus 1 equals 0. What times what is 1, but when added together is 0?
X plus 1, x plus 1.
X plus 1, x plus 1. Very good. So what does x equal? Negative 1. Can I have a negative 1 here as a denominator? No, because that would be 0. So here, there are no solutions. It's all extraneous. In this case, it does not work. This is an extraneous solution. Hence, exactly like I wrote extraneous. Yes, sir. It's exactly what you do. Thank you, sir. Thank you for asking, sir. Thank you. Okie dokie now. Okay, guys, so let's do this one now. We've got x over x minus 3. Excellent. Plus x over x plus 3 equals 2 over? Excellent. Difference of squares, x plus 3, x minus 3. So what's my LCD? So I'm going to multiply every single numerator by x plus 3, x minus 3, x plus 3, x minus 3, x plus 3, x minus 3. You guys with me? The x minus 3's cancel here. What am I left with, brothers? X squared plus 3x. Spectacular. The x plus 3's cancel here. What am I left with, brothers? X squared minus 3x. Spectacular. And here? 2. Excellent. X squared plus x squared is 2x squared. The 3x minus 3x cancels. Equals 2. No. Subtract 2. Well, no. If you divide, okay, here's the problem with that. If you divide a 2, I'm so proud of you guys for saying that. If you divide a 2, you're going to lose one of the factors. You always got to set this up so you can factor it out. I'll show you what I mean. Watch. This is 2x squared minus 2 equals 0. Factor out a 2, right?
Yes, sir.
Oh, no, but either way, actually, in this case, it didn't really matter.
X squared equals
No, it's not.
x plus 1, x minus
You have x squared minus 1 equals 0. Okay? Add 1 to both sides. X squared equals 1. Now, how do I get rid of a power of 2? Square root it. So I square root both sides, and x will equal plus or minus 1. That's not a difference of squares, no. That's a square root. It's a very simple square root. Guys, what's 1 times 1? And what's negative 1 times negative 1? No, what's negative 1 times negative 1? Whenever you're solving an equation and you have a square root, You're going to have a plus or minus answer. Yes.
Last said 2 on the outside.
Does you use a zero product property? Does 2 equal 0? No. If you want, guys, let's just go a different route. There's more than one way to skin this cat. Okay? I had 2x squared equals 2, right? Divide by 2. X squared equals 1. How do I get rid of a power of 2? Square rooting it. X will equal plus or minus 1. Whenever you use a square root to solve an equation, you have a plus or minus. For example, if it was x squared equals 4, the square root of 4 is plus or minus 4. I mean, plus or minus 2. Because what's positive 2 times positive 2? And what's negative 2 times negative 2? So you could have two options. You could have the positive side or the negative side. Talk to me. Sir.
Like before, you had 2 x squared minus 1. You could have done it to a squared, you have the same answer.
2x squared minus 1. What?
But you had 2 times x squared minus 1.
Oh, yeah, you could have done a difference of squares. You know what? You're absolutely right as well. Another way to skin that cat. I'm so proud of you guys. You had 2x squared equals 2. Subtract the 2. 2x squared minus 2 equals 0. Factor out a 2. That's x squared minus 1 equals 0. That's 2 times x plus 1. X minus 1. Beautiful. That even works better. That's even smarter because we haven't really worked with radicals. You are a genius. So zero product property. 2 equals 0. X plus 1 gets set equal to 0. X minus 1 gets set equal to 0. 2 equals 0, that doesn't work. So x equals 1 or negative 1. And then we go back up here. Can I have x as a 1 or a negative 1 here?
Yes.
Absolutely. And that'd be my solution. Great job, son. Excellent. Very proud of you. That's better because that way you don't have to worry about the radicals yet because we haven't done that yet either. Great job. We're good? Okay. Now, solve each rational expression for the given variable. Remember how we did this before, how we did, it's called literal equations. We're solving for an actual variable. You're going to use the same exact technique here, guys. Let's get rid of the denominator, okay? What's the LCD here? There's a 1 here. What's the LCD? So, multiply 1 plus y to both sides first. Why, Mr. Morrow? Because I'm solving for y, so I need to get y in the numerator. So this 1 plus y cancels out. I've got x equals z times 1 plus y. I want to get y alone, so I'm going to divide by z to both sides. X over z equals 1 plus y. Subtract 1 to both sides. So x over z minus 1 equals y. Cake. Exactly. Does that make sense? Now, some people are going to say, can't you just cross multiply? Yeah. Same thing. Same exact skill. Here, I want to multiply for x. I've got an x in the denominator, man. So how do I get rid of that? I want to get it to the numerator. So what can I do to both sides? You do switch the r and the x. You do. But what's the mathematical reason behind it? Good man. You multiplied x to both sides. And then you divide r. Now, my boy here, well, these x's cancel. My boy remembers this from extraneous, from when we were doing literal equations. And he remembers, oh, I can just switch the r with the x. But mathematically speaking, this is why you can switch the r with the x. Now, if you're on a test, on a quiz, on an SAT, can you just immediately go, oh, this is x equals 4g over r? Yes, I will accept that. However, I want you to understand the why behind it. It's because you multiplied the LCD to both sides and then divided by r. Does that make sense, my brother?
Yes, sir.
Thank you, sir. We're good?
Yep.
Last but not least, okay, here's the fun part. Here's where you can't just replace something. What's the LCD here, my brothers? So I'm going to multiply x, y, z to every single numerator. Here, the x cancels. I'm left with y, z. Equals. Here, the y's cancel. I'm left with x, z. Plus, here the z cancels. I'm left with x, y. Now, here's where a lot of people get confused. Do you see how I have a y on both sides of the equation? Bring them both together. Now I have yz minus xy equals xz. Factor out a y, my brothers. Aha, yeah, I heard that. Oh, yeah, it makes life easier. I love that sound because it means that people are learning. Now divide by z minus x. And guess what, boys? Y equals xz over z minus x. It's cake.
It is.
Okay, go. Someone went, what? Tell me. Talk to me. I'm here for you. Okay, last but not least, S equals A over 1 minus R.
Just multiply the
Thank you.
one plus r.
Beautiful. You multiply the LCD to both sides. So this is S times 1 minus R equals A. Done. Have a good one. Bye-bye. Does that make sense, gentlemen?
Yes, sir.
Thank you so very much for an awesome class. I hope you learned a lot, and God bless you. Bye-bye.